force due to liquid pressure, where the formula, okay, the force is represented by F, and it is equal now to the integral of WHDA from A to B, where W here is known as the weight density, then the H is the displacement, and dA is differential area. Okay? So let us apply this formula, force due to liquid pressure. In this example, we are given here surface area submerged vertically in a fluid is a rectangle 10 feet wide and 8 feet deep, with the upper edge lying in the surface. Find the force on one side of the surface. So let us now sketch the situation here where we have now a surface area submerged in a fluid vertically is a rectangle which is 10 feet wide and 8 feet deep, with the upper edge lying in the surface. So if we have this now as the surface area submerged vertically in a fluid with the upper edge lying in the surface. Okay, so let us have the x and the y axis shown also from here. Okay, let us identify the dimension, 10 feet wide. So we have this as 5 feet and 5 feet because this is 10 feet, okay? So let us have this as the origin. And then we have now the depth of the surface, which is 8 feet deep. Okay, so let us have this as the width. Okay? So the length is 10 feet. So, in defining now the force due to the liquid pressure, so we have the integral of WHDA from A to B. Okay. So, we are not given weight density. So, our answer is expressed in terms of weight density. Then what will be the height? The height is taken from this position where we have a strip, and this strip will define now the area or the differential area. Okay, so we have this now as if we let this as y and this as the height now or the displacement. So the height will be, since it is 8 feet, the width of the section here, rectangular section, so it will be 8 minus y. Okay? So we have that, 8 minus y. What about the differential area? For the differential area, since this is represented by a rectangular strip, we have this as length times width. So the length now, let us get it from the length of the section here, which is 10, and the width of the rectangle is represented by the strip, which is perpendicular to the y-axis. So we have this as 10y. Okay, so that will then be your differential area. So substitute here now, we have 10 dy. And we have the limits from 0 to 8. And how is this 0 to 8 obtained? Because we have the width of the section or the surface, which is 8 feet. Okay, so we base it from the height of the surface. Okay, so with that, we can now compute for the force. So that is now, simplifying it, we have, let us have this as 10 W, then integrating now 8 dy, we have this as 8y, then minus y squared over 2. From what limits? We have this as from 0 to 8. Okay? Then you have now 10w, then you have now, applying the limits, so we have 8 times 8 minus 8 squared is 64 all over 2, that is 32. So we have this now as 10w, then 8 times 8 is 64 minus 32. So the answer here is 32 times 10. So we have this now as force equals 320 W. So that is in terms of the weight density of the given fluid. Okay, let us have now the second example. Let us read the second example here. The cross-sections of a throw is a parabolic segment, 8 feet wide and 4 feet deep. If the throw is filled with a liquid weighing 45 pounds per cubic feet, find the total force on one end. Okay, so let us draw again the cross-section that is being submerged or it is filled with a liquid. Okay, so it is a parabolic segment. So let us draw the x and y axis first. Okay, so suppose this is the surface of the liquid. Okay, so we have this now as the parabolic segment, which is cross-section of a throw. So it is 8 feet wide, so let us have this as 4 feet and 4 feet. Okay, and it is 4 feet deep. So we have this as 4 feet deep. So we're going to find the total force on one end. In finding the total force on one end, again we have the formula to be used. That is the integral of W H dA. Okay, so W is given as, we have the weight density. So it is 45 pounds per cubic feet. Okay? And then we have the height. The height can be obtained by, okay, let us draw again here a horizontal strip. Okay, so let us define the endpoints of your parabolas. This is point xy, and this is point negative xy. Negative xy because it is on the second quadrant. Okay? And if we're going to define now the dA, okay, so for the dA, we have this as length times width, and the length is can be obtained by defining now the points on the ends of the rectangle, which is abscissa right minus abscissa left. So that is x minus negative x, or that is now x plus x equals 2x. Okay? What about now the width? The width is again represented by this strip, which is now, since it is perpendicular to the y-axis, so it is now dy. Okay? What about the height now? For the height, for the displacement, since we have this as y, and the length or the width of the parabolic segment is 4 feet, so we have this now h equals 4 minus y. Okay? So that is now 4 minus y. Then we have dA is 2x dy from A to B. And what is that A to B? A to B is from 0 to 4. Okay? Sorry. This is 0 to 4. Now, let us now multiply 45 and 2, and then let us replace x. What could then be the x? The x can be obtained from the equation of the parabolic segment. Let us define the parabolic segment here. Okay, so that is, we have now the equation of this parabola is opening upward. So therefore, it is x squared equals 4ay. Okay? And if we select a point here on the end of your parabola, let us set this as 4, 0, and the vertex is at 0, 0. So let us make use of 4, 0. Okay, so we define now the equation of the parabola and express x in terms of y. So we have x is 4, so that is now 16 because it is squared. Then equals 4a. Okay, sorry, this should be 4, 4. Okay, this should be 4, 4, not 4, 0. And then what is then a? A equals 1. So with that, we can now define that x squared, the equation of this parabola is x squared equals, replacing now a with 1. So x squared equals 4y. Okay? And then what is now x? X is now square root of, or 2 square root of y. Okay? So with that, let us have now. So the force now is equal to 2 times 45 is 90. Then we have the integral of 4 minus y. What about then x? X is 2 square root of y dy from 0 to 4. So we may now compute for the force. So by integrating it, okay, so let us simplify first. We have 90 times 3 is 180. Then we have now integral of 4 square root of y minus y raised to 3 halves dy from 0 to 4. Then this is the 180. So integrate now. So this is 4y raised to 3 halves. The reciprocal of 3 halves is 2/3. Then minus y raised to 3 halves plus 1, 5 halves. The reciprocal of 5 halves is 2/5 from 0 to 4. Okay? So this is the 180. Then you have now 8/3. Then 4 raised to 3 halves. Minus 2/5. Then you have 4 raised to 5 halves. So we have now 180. What is the square root of 4? That is 2. Then cube 8 times 8, 64 over 3. What about here? You have 4, square root of 4 is 2 to the 5th, 32 times 2, 64 over 5. Okay? Then simplifying it, what do we have here now? Force is equal to 180. Get the LCD from here. So this is 15. Divided by 3 is 5 times 64. That is 320. Minus, you have 15 divided by 5 is 3 times 64. That is 192. So computing it now, we have now force is equal to 1,536 pounds feet. Okay? Example number 3, the vertical end of a water throw is an isosceles triangle with a width of 6 feet and depth of 3 feet. Find the force on one side when the throw is filled with water with weight density of 62.4 pounds per cubic feet. Okay, so to solve this problem, okay, let us draw the cross-section of this throw, which is an isosceles triangle. Okay, so suppose it's the surface of the liquid, and we have this as the x and the y axis. So we have now an isosceles triangle drawn from here, okay? So when we say isosceles triangle, two sides are equal. So we have a width of 6 feet, so let us have this as 3 feet, and then the other one 3 feet. So a total of 6 feet, okay? Then a depth of 3 feet, so let us have this as 3 feet, okay? So the throw is filled with water with weight density given as 62.4 pounds per cubic feet. So we're going to find the force on one side. So computing now for the force on one side, which is represented by F. Then we have the formula WHDA from A to B. So the weight density is given as 62.4 pounds per cubic feet. and we have the height. The height can be obtained. Okay, let us draw a strip here, which is a vertical strip. So if we represent this as y, and we represent this as h now, h will be the total length, or the total which is 3 minus y. Okay, so that is now the h, 3 minus y. What about the dA? The dA can be obtained by taking now the distance between these 2 points of the strip, where we have this as point xy, the other one is negative xy. So that the width now is abscissa right minus abscissa left. Okay, so that is now x minus negative x is 2x. Then you have the width, which is represented by the horizontal strip, which is now dy. Okay, so let us have that now 2x dy. Okay, so let us express x in terms of y. And how do you express x in terms of y? Because we cannot integrate this without expressing x in terms of y. We can get it from the graph or from the figure here. Since we know that this is an isosceles triangle, so we have this as line, no? One side is a line. Of course, the other side is also line. So let us take one side. So we have this point here as 3, 3. And then we have this as 0, 0. Okay? Why 3, 3? Because you have the width of the draw, which is an isosceles triangle, is 6 feet, and then the depth is 3 feet. Okay? So with that, let us define the slope. The slope is, for this line is y2 minus y1 all over x2 minus x1 as the formula. So therefore, it is 3 minus 0 all over 3 minus 0, or 3 over 3, or 1. Okay? And in defining now the equation of this line, so we will use the formula y minus y1 equals m times x minus x1, where we have the slope now is equal to 3. But what about x1 and y1? We can get it from 0, 0, or 3, 3. So let us just use 0, 0. Okay? So let us now define now the equation of the line. So y minus 0 equals m is 1 times x minus 0. So therefore, simplifying it, y equals x. So let us now replace x by y. So therefore, this is now 2y dy. So what is then the limits? The limits will be from 0 to 3. So that we have now 62.4, then times integral of 3 minus y, then you have 2, what is xy dy from 0 to 3. Okay? So computing now for the force now is equal to 62 pounds-feet. Okay?